So in 1745, Needham was a scientist that wanted to support spontaneous generation. And after Reedy's meat experiment, people started thinking maybe there's something, flawed by the spontaneous generation theory. So Needham said, you know what, here, I'm going to run this experiment. And he took a broth. So he took a flask that had different nutrient broths in it, different types of nutrient broth, and he boiled that flask, making sure there was no living things in it. And once the flask cooled, he was able to see that there was life teeming in the flask. And he was like, hello, spontaneous generation. There was nothing here. I killed everything. So here it's cooling, and now after a couple of days, there's life. So Spallanzani said, John, you ran that test, but you had it open to the air. And there's probably microbes in the air that got into the broth. So what he did was he ran two flasks with the same fluid in each, boiled both, but one of the flasks he corked so that it was sealed from the environment. And the flask that was corked was sealed from the environment. After cooling, after days, nothing was growing. And he said, see, living things in the environment got into your fluid because you had an unsealed flask. And Needham answered that by saying, no, Lazaro, because Lazaro Spallanzani was his name. He said, Lazaro, that's not what happened. I know this because, or I believe this because I believe that nothing grew in your corked bottle because there is a life force in the air, something that in the air that needs to get to the fluid to be able to produce life. Well, we know that's actually correct, but the life force is life. It's bacteria that are living in the air. And so there was still, 100 years later, people were still going, which way do we go? Which way do we go? We don't know, Now we have a lot more pull away from spontaneous generation, but most people still believed spontaneous generation was the correct theory. But it wasn't until Louis Pasteur came along and he was able to discredit spontaneous generation. And we now know the new theory is called the theory of biogenesis. Living things come from other living things. And how Louis Pasteur did this was he made this swan-necked flask. So you can see this flask here. He was trying to figure out what could he do to allow a bottle to get air into it, but still not, if there's bacteria in the air, which he was pretty sure there was, if there's bacteria in the air or microbes in the air, not allow the microbes in. And so he made this long glass swan neck that allowed air to move through, but microbes would get trapped in the long neck. And he was able to boil solutions and let them sit for months and months and months, and nothing grew. It wasn't until he actually tipped the flask, allowing the broth to get to that neck there, that he was able to see, or that microbes would start growing. Or if he just broke the flask, he was able to see microbes growing relatively quickly. So within days of either tipping the flask and allowing microbes to mix with the solution, or breaking the top, there was living things again. So now we know that life only comes from life. The vital force in the air was living microbes that were getting into the solutions. even though Pasteur was able to prove that living things were obviously coming from living things, not everyone wanted to accept that. And part of the reason was because Pasteur's results weren't always reproducible. John Tyndall was able to explain that some individuals will get different data dependent on what's going on, or not what's going on, what the environment is that they're working in. So Pasteur worked in a laboratory, more of a sterile environment, whereas a lot of scientists worked in the back of their barns. And if you have a science lab in the back of a barn, you're going to have a different environment. You're going to have different microorganisms living there. One type of microorganism that often is found in barns is called Clostridium. And Clostridium produce these things called endospores when they can't survive in the environment. And so what scientists were finding was that sometimes the results would support Pasteur. Other times they would get living things. Tyndall was able to explain that if the experimental design, so if the environment and everything is not exact, that you may get different results. And what he figured out was that in hay broth, there are these microbes called heat-resistant microbes, which now we know are endospores. And these endospores are often found in hay, which if you're running your experiments in a barn and you're using hay broth versus running your experiments in a lab using sterile broth initially, or using maybe not sterile broth, but using so using some other type of a broth and then sterilizing it, you're going to have different results. And here's why. We have two different types of microorganisms. One is called a heat-resistant microbe, and these microbes, when they enter an environment that is not conducive to life, they produce endospores that can stay in the environment, persist in the environment until the environment is more conducive to life. The other type of microbe is called a non-resistant microbe, and those ones will die if the environment becomes unfavorable. And we now call the heat-resistant microbes endospores. And in our lab, we'll be playing with one type of endospore former called Bacillus cereus. So you'll get to actually see these endospores. Microorganisms are not actually harmful. A lot of people like to jump and think, oh my gosh, we're studying microbiology, and that means we're studying disease. Well, microbes can cause disease, and some of the worst diseases on Earth are caused by microbes. But most microbes are actually beneficial to the environment. They're beneficial to the human ecosystem. They produce foods that we eat, drinks that we drink. They're used to produce clothing. I mean, they're used in everything. So they're very beneficial, but we do have to give props to those pathogens that cause disease. So though most microbes are beneficial, those that are pathogenic can cause some of the worst diseases on Earth and can wipe out huge populations. Example, influenza killed millions upon millions of Americans. More than World War I, World War II, Korean, Vietnam, and the Iraq War, all combined killed. So these are two figures that show different diseases that were more likely to kill you. In the 1900s, people worried about pneumonia, tuberculosis, diarrhea, enteritis, which is gastroenteritis, where your intestines are inflamed. Not as many people were worried about heart disease or stroke, liver disease. Those things weren't as thought of. But down in 1997, so a lot closer to now, we have heart disease as our #1 killer. So, you know, a lot of these things have changed. I mean, if you look down, pneumonia and influenza are way down on the list. They're not that commonly thought of as killing diseases anymore. Whereas those two were really important in the early 1900s. So what do you think might have changed from the beginning of the 1900s to the end of the 1900s? So I'm not going to talk about it on here because that'll be something we can talk about in class. It's one of our discussion points, okay? All right, I'm going to stop on this video here. We'll talk about Agostino Bassi and what he did for immunology in our next video.